Welcome to the ISC2 Toronto chapter, where cybersecurity professionals come together to learn, connect, and grow.
Joining our chapter means joining a community of like-minded individuals dedicated to advancing the field of cybersecurity.
Whether you're a seasoned veteran or just starting your career, our events and resources cater to all levels of expertise.
Being part of ISC2 Toronto has helped me stay up to date with the latest trends in cybersecurity.
The networking opportunities that I've made here have been invaluable.
I've made connections that help me both professionally and personally.
From monthly meetups to special guest speakers, there's always something happening at ISC2 Toronto chapter.
Join us today.
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 Join us today and take your cybersecurity career to new heights with ISC2 Toronto chapter.
And now that's out of the way, good evening, everyone. My name is Abimbola Adegbite, in case we've not met before. Welcome to the ISC2 Toronto chapter June workshop, and I'll be your host for this evening. Before we dive in, how about we have a little laugh? I know I'm just getting used to being a dad, so I have quite a number of dad jokes up my sleeves. But again, has anyone ever wondered why the keyboard never sleeps? Anybody?
No, why?
Because the keyboard has two shifts. If you don't get it, forget about it. Bliss, just bliss. Ignorance is good. Anyway, thank you all for joining us once again. We are excited to have this dynamic workshop lined up for you. And today we'll be focused on enhancing your application security skills. Our speaker tonight is a seasoned cybersecurity expert with extensive, I wanted to say expensive. Yeah, expensive because it costs money, but extensive is what I meant to say. Extensive experience in application security. We are thrilled to have you all here, and I hope that this session is as valuable and engaging as we have planned it to be. Moving on to the next slide. So just welcoming you once again. Again, this session is being recorded, and and in case you missed that, because you're just joining, photographs and screenshots may be taken for the chapter's marketing purposes. And to ensure the best experience for everyone, please keep your video off and your audio muted until the networking session. Additionally, CPEs will be granted by filling out the survey that will be shared towards the end of this presentation. And before we continue, it's important that we acknowledge the land that we are on. ISC2 Toronto chapter respectfully acknowledges the deep and enduring relationship that the First Nations, Inuits, and Métis peoples across Canada have with the land we all share and cherish. We express our gratitude for the opportunity to live, learn, and work on these lands. This event takes place on the traditional territories of many nations, including the Mississaugas of the Credit, the Anishinaabeg, the Chippewas, the Haudenosaunee, and the Wendat peoples, and others who have called this region home for countless generations. We acknowledge their profound wisdom, cultural heritage, and dedicated stewardship to these lands. Next slide. Sorry, my keyboard has not slept, so it's misbehaving. So before we get to introduce our speaker for today, please note that all views expressed are the speaker's own and not of their employers or any organizations or groups with which they are associated with. Very quickly, let's introduce to you ISC2 Global, just in case you're wondering what are we doing here? We're gathered here because of ISC2, and ISC2 Global is a 600K member candidates and associates strong with over 150 chapters worldwide. ISC2 is the world-leading cybersecurity professional organization. Founded in 1989, the goal of ISC2 Global is to include standardization and certification in the cybersecurity industry. ISC2 Global is committed to educating the general public through the support of the Center for Cyber Safety and Education. Of course, we're all familiar with CISSP, flagship cybersecurity certification, which is administered by ISC2, and there are quite a number of other certifications offered by ISC2, and they are considered the gold standard of the cybersecurity industry. Moving on to our chapter, ISC2 Toronto chapter, we have over 500 members, candidates, and associates with 245 certified members. Our key objectives are to promote and advance the profession, create educational events and opportunities like this one, connect and advance InfoSec professionals across the Greater Toronto Area. Now, moving on to our guest for tonight, Casey. Drumroll. I'll just quickly introduce Casey and I'll hand it over to him. Casey has been at the forefront of designing and developing cybersecurity software for over 2 decades. His early career highlights include pioneering the first intrusion prevention system on the market, creating a groundbreaking vulnerability management system for the US Department of Defense, developing training programs that laid the foundation for what is now the US Cyber Command. Now, while working with the Department of Defense, the US Department of Defense, Casey expanded his expertise to offensive cybersecurity solutions while ensuring the robustness of deployed defensive systems. He contributed to the early development of Nessus, which is now known as Tenable, and he spearheaded the development of the largest offensive scanning program on the internet at that time. While in the past 5 years, Casey has shifted his focus to offensive AppSec, aiming to scale security measures to match the rapid pace of modern software developments. Casey, over to you at this time. I'll stop sharing so that you can take over.
Excellent. Yeah, thank you so much for having me. Make it into presenter mode here. Says I'm not able to share.
Oh, okay. Let's make that change now.
All right.
Okay. I can share your slide while I figure that out. Just a moment. I'll share my screen instead. I think I have the wrong screen. What can you see at this time? Slido or?
I see just the intro slide, so you probably skip to the slide 3.
Slide 3.
Yes. Yeah, we don't need to beleaguer my experience.
For some weird reason, I can't even see what I'm sharing. Okay, I'll reshare again. Just a moment. Demo days at Demon Days. Okay, this should be different now. Okay, this should work. Can you see the slide now?
Yeah, first
All good?
slide. Yep.
Okay. So I'll let you take it from here.
Yeah, if we can skip to slide 3, then I can get started there.
Okay.
We already did that one. All right. So, oh, going too far forward now.
Oh,
One back.
there you go.
So I'm just wanted to start by setting a little context. I presume most people here have some experience with InfoSec. Not sure how much experience there is in AppSec. So I want to kind of draw, compare the two, because they are both cybersecurity. They're both related to defending your assets and your infrastructure, but they follow different rules, and for pretty good reasons. So in InfoSec, this is a world ruled by CVEs, right? The common vulnerability exploits. And this is often because in InfoSec, you're running software that someone else wrote, not software that your company wrote or that you wrote. So often the exploits or the vulnerabilities found are discovered by the community, security researchers, security teams at big companies like Microsoft or Oracle or whomever. And then they publish their finding, and the community reacts, right? We're probably all well aware of the famous 0 days like Heartbleed and Log4Shell and et cetera, et cetera. Most of these are in open source software, and that's mainly just due to the fact that because the open source software is available, there's more people looking at it and more researchers poking holes in it and things like this. And as I highlighted here, these are lots of potential vulnerabilities. And that's an important part or important distinction between InfoSec and AppSec. And we're going to talk a little bit more about that later on as I go through the particular subset of AppSec that we'll be discussing, which is dynamic security testing, and specifically dynamic security testing for your software pipeline. So, and the reason they're potentials is because, as you've probably seen from many CVEs that come out and you respond to, you'll look at it and say, well, does this actually affect me? Am I running this particular configuration and things like that? So that's why I put them in the class of potential vulnerabilities. AppSec, on the other hand, is again not focused on the software you run, but the software you build. So this world is dominated by CWEs, which is the common weakness system. So this both run by MITRE. They're similar. CWEs are far less. So there's CVEs, they every year there's a whole new ones that come out, and you have to keep track of all these different numbers that kind of correlate to specific vulnerabilities, where CWEs are a lot more broad in scope. So there'll be kind of categories. Think of the OWASP top 10 and things like that, where they cover a general area of weakness. To address these, there's just a very different set of tools and techniques used. So bug bounty programs is one of the most popular right now, which is essentially saying, hey, community, I know you can't see my software, but here's my APIs. Come test me for common weaknesses and see if you can exploit it and report it ethically. Black box testing has been kind of the tradition for this with DAS tools and kind of testing from the outside. Think of pen testers and all of those kinds of things. There's a lot more kind of obscurity going on because, again, oftentimes the source code is not available, or nobody even knows how the software works outside of the company. So it's just a lot more obscure as to what is actually happening. The thing that I do find interesting about AppSec in general is almost everything is a 0 day because it's new software being written by your company or your organization. Also, traditionally, this has been a heavily manual process. So I mentioned pen testers, bug bounty programs. These are humans taking the time to go find these vulnerabilities. However, the more exciting part is that almost everyone found is a real exploit. So unlike CVEs, where you have to kind of dig through and figure out, does this actually affect me? If it was found, it's a 0-day and it's essentially exploitable. So that's kind of just setting the groundwork for the next part of this. So if you can take me to the next slide. All right. So if anybody's been in cybersecurity for any length of time, you get into this murky water problem. So when a CVE gets released, there's often a scramble. People are rushing around trying to figure out, does this affect me? And then you start negotiating, right? You talk to your IT folks, you talk to your DevOps folks, your developers, and this back and forth starts to happen where there's all this negotiation around, we don't use it this way, or we don't configure that option in that particular library, so that's not a problem, or we don't run that particular Nginx module, so that's not an issue for us. So you get into this really interesting set of back and forth in InfoSec with that. So and often, a lot of times CVEs have these really narrow use cases, which is another kind of difference between AppSec, where in AppSec it's either there or it's not, and that's not totally true depending on the tool you use, but that's where dynamic testing really comes into play. So next slide, please. All right. So enough of the contrast and compare with InfoSec. We'll get right into AppSec. So in AppSec, there's three main classifications of tools. Some of these are changing now, especially with some cloud native tooling. There's some new kind of subgenres of these. But at the end of the day, you have software composition analysis, SCA, static application security testing, and DAST. I have DAST highlighted here because this is what we're going to be focusing on in the workshop. As you can see, I kind of tried to compare the different tools and what they're based on. SCA is a lot like InfoSec. It's still CVE based. It's fast to run and detect. So this is often the first AppSec tool that people put into their software development lifecycle. Dependabot is a classic one, right? That's been around for a while. SonarQube and Checkmarks, they all make tools that you just add the plugin or the GitHub action or whatever build system you're using, and every PR your developers check in code, it looks at all the dependencies in whatever language or framework they use, and it very quickly tells you if there's a matching CVE. And that tells developers, hey, I need to upgrade this. Now, similarly, with CVE-based systems in InfoSec, you have a similar back and forth of, well, does this actually affect me? Do we use this library this way? And sometimes it's even more complicated because the developers maybe can't update to a new version, and you can get into some trickiness there. They're often noisy as well. If they're not tuned well, you have a lot of things complaining that aren't going to actually affect your application at runtime. So there's often a lot to deal with there. SAST is another kind of a more emerging tool. I don't see it used nearly as much as SCA, but companies like Sneak have really made this a very popular DAST or application security tool for the pipeline. There's also SemGrep and many others. You listed a few of the companies here, but there's quite a few. It's fast. That's another reason developers love it, and they love having it in the developer pipeline, is they runs generally very quickly. However, it can tend to produce a lot of false positives because they are looking at code for patterns. And as we know, code can be highly obfuscated depending on your framework, how your developers work, and it can be noisy. It's another one of these. Sometimes it generates more things to look at than problems it's solving. This, however, starts to get into more of the CWE-based approach to things. So with CWEs, again, it's a common weakness. So SAST, a SAST tool is never going to tell you, hey, this definitely has a vulnerability. It's going to say, this looks like a vulnerability because let's say you didn't parameterize your query builder or something like that. So that's a potential SQL injection. It may not have all the context to know for sure, but it's a good way to start kind of creating a stopgap for AppSec to make sure there's, excuse me, to make sure your developers aren't checking in just blatantly bad code. But again, noisy, lots of false positives and false negatives, and can be tricky to tune. So DAST, of course, I'm biased because this is the tool set that I work on. But DAST is unique. It's not as fast to run, but has a lot less false positives. It's also CWE based, so it's doing it's checking for common weaknesses, not looking for specific vulnerable packages or specific CVEs. Excuse me. Spam. There we go. So that's one of the unique parts of DAST is when it finds something, it's generally an exploitable problem. And I say generally because there's no tool that is truly false positive free. So there's also kind of this concept that you'll see in the marketplace or kind of cybersecurity experts talk about where there's old DAST and new DAST. And I even kind of highlighted some people are just not calling it DAST anymore at all. They're just calling it API security testing. So when you look at tools, you have to kind of look critically at which ones are more modern and take on more of an approach of testing APIs and more modern web stacks as opposed to kind of Web 1.0 and Web 2.0 web applications. So a lot of vendors in this space. Obviously, I put StackHawk in there. That's where I'm the chief architect at. So that's the one we use. ZA Proxy is an open source tool that something you can use for free and you can practice on. It's not going to be as polished, of course, as some of the purchase products. And Escape and BrightSec are two companies that are also kind of considered more new DAST and modern, and Vericodes kind of falls into the older DAST one. One of the things that DAST has been kind of left aside with is being used in the software development lifecycle. But companies like StackHawk and Escape and BrightSec and some others are very much have shifted DAST left, as it were, and shifted it to be automated and run in the pipelines and work similarly to the way SCA and SAST have for quite some time now. So next slide, please. Okay, so let's get into some of the meaty stuff. So with DAST, unlike SCA and SAST, where you can kind of just point the tool at a code base and say, show me what you found. With DAST, it becomes, or dynamic testing in general, and API security testing falls into this same thing, is you need to be able to practice, and you need to be able to understand the apps and the frameworks that you're going to be testing. And there's a lot of good training apps out there. I've listed kind of 3 or 4, and the one that we're going to be working with, which is the one we developed at StackHawk, and they serve different purposes. So it's worth checking them all out and seeing what they do. So, for example, DVWA is often used for benchmarking tools because it doesn't hide any of its vulnerabilities, and it's meant to kind of almost be like a smoke test for the tools themselves. In contrast, you have projects like Juice Shop, which is very much a training tool for pen testers and bug bounty hunters, where it is just filled with nuance and traps and false positives and false negatives and just all of the things as a practitioner that you might run into in a real world app. In fact, so many things it's almost hard to teach with because it's not very realistic. Like if your application at your company is as bad as Juice Shop, you've got way bigger problems than any tool is going to solve. But these vulnerable apps and practicing with these vulnerable apps, which is what we're going to get into in the workshop today, is a great way for for you to take your cybersecurity knowledge and kind of put yourself in the shoes of the web developers and see where your two worlds kind of meet. So that's one of the things I talk about here is, take the time. If you're responsible for an AppSec program, take the time to learn your stack. So it doesn't mean you have to become an expert in React or GraphQL or whatever technology it is, but take the time to understand which version of GraphQL they use, what libraries they use. Are they using the Java-based ones or the Node.js-based ones, or what frameworks are they using? Are they using Spring? Are they using Express.js and things like this? And the reason I say that is each one of those can kind of produce unique results when you're doing dynamic testing. And if you know about them and you know some of their characteristics and you work with your engineering team to understand those characteristics, you can make your automated testing significantly more effective, and eventually find more vulnerabilities and save everyone a lot of time. I skipped over it a little bit on the last slide, but one of the other big differences between kind of old DAST versus new DAST, as some people are calling it, is this concept of being gray box. So in the world of pen testers, it's very black box. You go, here's my website or here's my domain, attack it. And the pen tester uses all their tools and skills to probe and figure out what is going on behind the scenes. Where if you want to automate dynamic testing in your software pipeline, it actually helps for you to know a little bit about the app. And that's because you can give it better context. You can give the scanner better context. So this is often called gray box testing. So it's not white box testing where like SAST and SCA, you're looking right at the source code, but it's also not total black box. So it's somewhere in the middle. And one of the great examples of that, and we'll talk about a little later, is being able to use things from the framework to inform the scanner or inform the tool of how to better attack it. And so the best example of that is Swagger or OpenAPI specs. So we can go to the next slide. So lastly, it's already in the prerequisites, but we'll be using, for training purposes, we'll be using a vulnerable app we call Java Spring Vulny, and it is not filled with a ton of vulnerabilities. It just has a handful, but that's good for this purposes of this and kind of training exercises, because it will show a number of ways that you can configure it, a number of ways we can configure the tool to interoperate with it and kind of show that gray box testing. And yeah, we can go to the next slide. Oh, one back, please. All right, so security testing in the development pipeline. This is where the rubber meets the road, right? You have these tools. You have your web stack, your web developers, and all these different projects, oftentimes different types of code, different types of languages, different frameworks, different technologies, and you have to kind of marry these up. So this is a bit of a philosophy of mine and certainly of StackHawk, and part of why we started this which is just, we think of security testing as quality assurance. Like if you think of through the lens of QA, which is essentially saying, what is my business going to allow to be shipped in my software? What is the quality level that we wish to reach? The same thing can be said for security, right? Not all security vulnerabilities warrant stopping the development train, as it were. So similar to quality, you have to kind of weigh these different aspects. Also similar to quality stuff in the modern development world is all of it should be as automated as possible. So we truly believe that security tests should be run just like unit functional tests and integration tests. They should be a step in the pipeline. They should break the build. Ideally, they don't have to break the build. You can make things asynchronous. If you've worked at software shops where they run nightly tests or daily builds, you can still get just as much information about the quality, or in our case, the security posture of your code and your application, by running it nightly. It really depends on how your business ships software. Now, if you're a modern shop and you're a Netflix or a GitHub and you're shipping code to production, hundreds or thousands of times a day, you want to make your security program match that, and just like you would make your quality tests match that. So you would have it break on every build or run automatically on every PR. Similarly, use the same feedback loops. So in what I'm going to demonstrate with HawkScan, which is the name of our scanner tool, and with StackHawk's platform, and a number of other tools do this as well. And you can home grow these as well, is you want to build in these feedback loops that the developers are used to. So whether it's breaking the Jenkins build, or you fail a test and you automatically create a Jira ticket, or whatever your process is. Maybe you send a Slack message to the engineering team. It's what exact feedback loop you use really should depend on the organization and what the development and engineering teams are already used to. Focusing on enablement for your developers. So an unfortunate practice in security for a long time has been the security people run the security tools and developers write the code, and ne'er the twain shall meet. So if in the modern world, though, you really want to put the control into both hands. So focusing on, as a cybersecurity kind of professional, you want to focus on the program, the tools, the feedback loops, making sure that everybody's aware of what's happening and not getting so wrapped up in the individual findings and the individual vulnerabilities. That is definitely another one of those contrasts between InfoSec and AppSec, where in InfoSec, that's very much security's job. And then they have to go, as I stated before, negotiate with the correct teams to get patches on infrastructure. But if you set it up right for developers, you can often have the feedback loops going right to them, and then you can just measure the effectiveness of the program. How often do vulnerabilities get found on builds? What severity generally are the vulnerabilities that are found? And kind of take a step back from the day-to-day management of each of those. And this is really where the power of putting this kind of testing into your pipeline comes into play, because it scales. So we have a number of customers. That's the whole reason they switched to this style, is because they had AppSec teams, but they're shipping so much software at such a high rate, there's just no way their AppSec team could keep up. And so being able to scale out the program becomes critically important. And of course, you have to lean into the tools that you use, right? If you use Jenkins or GitHub Actions or Azure DevOps or GitLab, they all have amazing sets of apps and tools. Our app is available in their marketplace, as are many other tools, both open source and vendor based. So that's important to, again, just similar to taking the time to learn how your web development frameworks are being used and which ones you're using. Understanding your build pipeline tool becomes a critical part of making this program effective. All right. I think we're ready to get to some workshopping.
Okay, time to get our hands dirty. My understanding is that there are some prerequisites that have been shared in the chat box. So we're still unable to make Casey co-host. So while we're working on that, I will still continue to share my screen. So I'll stop sharing this one. I will share my main screen, and then I'll let Casey walk us through. Do you mind, Casey, if it's Windows or Mac?
It shouldn't matter. I'm more familiar with Mac, so that would help. Yeah, if we could figure out the share, that would be best. Otherwise, this could be a little slow.
Yeah, it could get tricky. Okay, I'll stop sharing, and then let me grab. So for folks, maybe we can use this time to quickly double check if we have all of the prerequisites set up, and just leave a thumbs up so that we'll know that we're ready for this.
There are some questions from audience as well.
Oh, okay. Maybe we can quickly take the questions in the meantime while we figure this out.
The first question is, the tool Burp Suite comes in which category? SaaS, DAST, or SEA? As compared to Burp, how can we test a website for vulnerabilities using HawkScan, CLI, or StackHawk?
So HawkScan is DAST, similar to Burp Suite, if I understood the question correctly. And it can be used similarly. Burp Suite is generally more manual. I know they have automated capabilities now, but that's essentially what I was gonna try to demo, which is how to create a configuration file for the scanner and how that will then send the results to the platform and where you can start to triage and manage them and things like that. Did I understand that question correctly, or? Hopefully I did.
Yeah, that was the question. Like, which category the Burp Suite comes under?
Yeah, so Burp Suite definitely is DAST for sure. It's a dynamic testing tool. Yeah, it's probably one of the oldest and longest around kind of pen testing suites, and so yes, Burp Suite is definitely DAST.
The next question is, how does StackHawk integrate dynamic application security testing into the CI/CD pipeline to enhance real-time security feedback for developers?
It's a great question. So part of that's part of what I was going to show, which is how our we've developed our tool a lot of the way that kind of other cloud native tools are developed. So we make the CLI relatively easy to install, as well as provide a Docker image from Docker Hub. So that makes it really easy to plug into things like Jenkins or other build tools. We also, in the marketplace, is GitHub Actions Marketplace and Azure's Marketplace, we ship official actions. So super easy to just add those into your build pipeline YAML, and then include in your repository the StackHawk YAML, which is the configuration file that tells the scanner what to target, what kind of tests to run, how to perform authentication, and a number of other those kinds of things. So that's basically how that ends up working, and the results get reported back to the SaaS platforms. So all your results, like if let's say you have 20 engineering teams or 100 engineering teams, each one of them could maintain their own YAML file in their code repo, and that would then be part of their build pipeline, and all of that rolls up into the SaaS platform where you can manage all the results as a security person. So.
One more question is there, like, how does StackHawk manage and optimize performance to ensure efficient security testing in high traffic, large scale application environments?
Oh, that's a good question. So there's part of the reason why we made this scanner the way we did, and we don't actually scan over the cloud. So a lot of some other like InfoSec scanners like Qualys and things like that, they run from their infrastructure, and you're adding a whole lot of latency involved when you do that. So our scanner is designed to be deployed as close to the application as possible. The other thing I would say is, and this is less of a technology solution, but more of an approach, which is don't run against production. These are, especially with our tool and a lot of DAST tools, they are designed to do bad things. They're designed to inject data and cause problems. So the way we scale out is by trying to scan the microservices as close to development as possible. So our preferred way of telling customers to run, and this varies based on your environment, is if you run an ephemeral instance of your application. So similar to the way a developer might spin up the app locally, and this is a common way to test, is you just spin up the app in dev mode and you scan it right there. So that doesn't have to be the case. Plenty of other users will deploy to their staging environment and then spin up the scanner. But again, the scanner is always as network close to the application as possible. So it doesn't seem like a lot when you talk about the difference. You talk about an HTTP request taking 50 milliseconds. But when you times 50 milliseconds by 10,000, 50,000 individual tests, the math suddenly gets large quickly. So putting it as the scanner as close to the application as possible is super important. And in that same vein, another common misconception with DAST is, well, I should test it like it is in prod. And I would actually say, no, don't do that. And this is where the gray box part of what I was talking about earlier comes into play, which is if you're testing in production, you're often testing through load balancers, WAFs, potentially rate limiters. And while all those things are great for production, they're just slowing down your ability to find the errors in your application's logic. So actually testing in a dev mode or in a test mode, much like a QA might, or like a load generator might, you can speed up the testing dramatically and scale out the testing a lot faster. So the kind of core thing is I would say there is, scan in development and test. Don't scan through a lot of infrastructure. And if possible, and this a lot depends on how your stack is built, scan is the smallest microservice possible. So instead of waiting until all your microservices roll up into your API gateway, scan them at their individual repo levels and in their kind of smallest unit possible. That's a great question, by the way.
Thank you. There are a lot of questions coming in. Are we good to go or?
Oh no, so just to be transparent here, Raphael is the host and he made us co-host. I thought that being a co-host would allow me to grant someone else co-host, but that's not happening at this time. So we have to find a way to make this work by me sharing my screen.
Okay.
All right.
It could get rough, but let's see what we can do. I have some commands I can kind of post into the chat to run.
Do you want to try now? Try that. I just modified one change here.
Oh, I got it. I can share.
Okay. All right. So
okay.
It's allow all type of responsibility, but
oh boy. Everyone be cool.
Yes, everyone.
Okay. Let's see. Hopefully everyone can see my screen. I dropped my resolution a little bit, so hopefully that is good enough. Let me see if I can see the chat here. Yeah, maybe if I can get some thumbs up. Is this a good enough resolution? A little not hurting people's eyes too much? Excellent. Okay. So I'm going to start with this is the project that I put in the prerequisites, which is like I said, it's Java Spring Vulny. It's hosted off of our open source GitHub repo. I made a fork of it into my own personal project, which is just recommended for anyone to do. And the reason I recommend that is if you want to test some of the things I'm going to show you, you can test in GitHub Actions on their free tier, so you can really see it run in the pipeline. But we won't get into too much more of that. So as the name implies, this is a Java Spring Vulny app. In the Java world, there's two main build tools. One is Maven and the other one is Gradle. This is Gradle, a Gradle-based project. And in Gradle, you run the command /gradlew, excuse me, which is essentially this script that is in the project itself. One of their other prerequisites was Java 17, which Gradle will take care of bootstrapping itself if you run this script, as long as Java is installed. So without further ado, I am going to start the vulnerable application. So that's the Gradle W boot run. And if you're running into just environment problems and setup things, it's all being recorded, and so you can come back and troubleshoot and ask questions and things like that later on. So this started up pretty quickly for me because I've already built the app a few times. And so as of now, we actually have a nice app running. It will run on HTTPS insecured, and we'll get into why that is, but on localhost 9000, and it's just this very simple application to do a little bit of testing with. One of the things that we do have in this application that a lot of other vulnerable apps don't focus on is authentication. So one of the core things of testing, dynamic testing, is often being able to authenticate to the application you're going to test. Most of the logic you want to test with, or test against, I should say, is going to be behind some kind of login. So this app has a lot of kind of fake auth modes to practice with and things like that. There is not a lot of functionality in this app. The username and password is just Jane Smith, and the password is password. We're not here to make a secure app. Again, this is a practice app to be vulnerable with. There's very little in the way of functionality, but one of the core things we have is this little search box. So this is an input that does hit an internal database of the app, so we can exercise some vulnerabilities against that. So, a little intro to the app. There's some other special URLs in there, like that. Log4Shell, everyone's favorite. So at this point, I am going to show the YAML configuration file that the HawkScan tool uses. So hopefully you were able to get the HawkScan tool installed. Again, I pointed to doing the CLI mode. There is a Docker image as well. It's a little more complicated to do Docker image just because, or at least when you're doing this locally in development mode, it's more complicated. It might actually be easier when you're in the development pipeline, depending on your systems. But if I run Hawk version, we should tell us kick out the version. We just know the tool is working. I've already run Hawk init, which is something you would need to run to initialize the tool with the platform. And let me and we'll talk about this command in a minute, but one of the primary subcommand of Hawk is the scan command, which I will explain what is going on here in a minute. But the important part is the YAML configuration file. So in this configuration file, StackHawk YAML, this is where we describe how to scan the app. So the main thing that's needed, technically the only thing that's needed to perform a scan, is the app host. So as you can see, this matches the URL from my browser. What you see going on here is just some variable replacement technology. So this is something our configuration file supports, and we'll take advantage of this in a moment. But this is this follows kind of templating standards that a lot of the cloud native tools come with, which is a lot of the design of our configuration file and of our tool. It kind of matches things like Helm and Kubernetes and other kind of cloud native apps. But these three pieces of information are required for our platform to scan, and I'm going to show you real quick where those come from. But the application ID is a unique ID that identifies essentially in our platform where your data is going to go for this app. So if you think in the context of managing hundreds of microservices, this becomes pretty important to help manage the data on the platform side of things, which I'll show shortly. The environment is actually totally free form. It's just a way to tag the data in whichever environment. So this becomes handy when you're doing things like scanning in both test development, or have different kinds of staging environments. It's just a way to tag the data. Right. So I'm going to go to the platform real quick, and my UI is going to look a little messier. If you were able to sign up to a free trial account, you would see a lot less apps, hopefully just the Java Spring Vulny. Looks like there's some questions. I can stop and try to help if possible. I know I do talk fast. Apologize for that. Let's see. Okay. How's everyone else doing? Some people are lost. Should I cover some other stuff real quick?
Yeah, someone said they are currently lost, so if you can help find them.
Yeah. Yeah, it's I know that the prerequisites may have had some challenges. Is there's something there that we can help with, or how to get the local, or if we're talking about the app running, the easiest way would be this command here. Let me redo that. So this is this command here, the Gradle w boot run. This should, if you run this in the directory of the repository, it should, Gradle should build the app and start it up in the foreground. Yes, please do slow me down. I do talk fast, and I forget that not everyone does what I do every day. So, but hopefully that makes sense to some folks. And this project is available for, whenever people want to hack on it. And if you're not familiar with Gradle and things like that, I can understand that. But hopefully you have the JDK 17 running, that or installed rather. That is definitely important. How long does it take to build? That kind of depends on your internet connection and pulling down dependencies. So it might take a little bit. Without knowing the speed of your internet connection, that is a tricky one. However, I have a shortcut for some folks. One moment. So if you are not interested, so part of the reason I was having people run the Gradle was so we could actually fix the vulnerability. But if you want to just get the app running, let me share a little something here. I'll post this in the chat as well. There is a pre-built version of the app on GitHub. So in this file, under the Hawkscan YAML, so in this project, there is an example GitHub action, and you can curl this pre-built jar and run the jar like this. The ampersand will run it in the background. If you do it without the ampersand, you can just run it in the foreground. And if you don't want to wait for the app to build, that will get you going much, much faster. However, you won't be able to fix the vulnerabilities, which is what I was going to show later on. All right. I know this is a big group of people, so I don't know how long we want to take. I'm sure everybody's gonna have a little bit of different adventure based on what system you're running and kind of the familiarities with these technologies. So
right. Plus, there's always the recording to fall back to if
absolutely
you need to ever catch up.
All right. So yeah, hopefully if the build is taking too long, or you don't your internet connection is not as fast as mine, I am lucky to have a very fast internet connection. Then download the pre-built jar, which should help. And I can keep this up. In fact, let me go ahead and just post this in the chat for folks to. That's the download.
Awesome.
And
Thank you.
to run it, you can just do that. All right. Okay, so I'm gonna get back to kind of the configuration file and things like that. So on the Stackhawk platform, as I said, when you create an application, it will create this unique ID that is important to put into config to match up where the data is going to go. So in this case, I'm going to show you here. This is my unique ID. And what's happening here on the command line that I have printed out is I'm saying hawk scan, which is this scan to say, hey, read this configuration file and perform a dynamic security test. The policy that will be used and a number of other things happen automatically from the platform. But the important part here is you see this app ID I have in here is actually not the app ID that I want. And I'm taking advantage of our templating system, and I'm telling the scanner at runtime to replace app ID, this variable, which I've defined here, as the application ID. So when I run this command, the configuration file will be parsed, and this app ID that I just pulled will be used. And the only reason I'm showing you that is just it's one of the nice ways you can use this config in a dynamic fashion. If it's frustrating or you don't want to do it that way, you can always copy your app ID and just replace this whole thing like that. And as long as that unique ID from your UI, from your platform and your account is the same, it should do the trick. I'm going to cover a couple of other things in here. This is some nice to have. This tells the scanner to wait for the application to start with a certain amount of time. This comes in handy when you're in a build system where you might launch your app in the background, and then you tell the scanner to launch, and it just tells the scanner to wait for it. The exclude paths, this is actually kind of important. Almost always there's some path you want to tell the scanner to stay away from. In this case, it's the log out path because we want to log in. So we want to perform a scan authenticated, and we would like the scanner to not log us out during that process, because if it did, it will kind of get into this authentication loop. This kind of configuration is heavily dependent upon your app. So if you're using JWT tokens or a different type of authentication, which is a lot more common in modern apps, this might not be necessary. It really kind of depends on the app. The anti-CSRF parameter, this is also important for this particular type of authentication we're doing. So the anti-CSRF parameter is the name of the parameter that's going to be included on all of your input forms. By telling the scanner what that value is or what the name of your CSRF parameter is, it helps the scanner know what to stuff and how to fuzz form inputs and things more effectively. So again, this kind of gets into some of the gray box stuff where you need to learn a little bit about how your app works to then make the scanner more effective at its job. And now we'll get into the largest section, which is usually the largest section of everyone's config, which is how to authenticate. In this case, I'm using the basic kind of standard form-based authentication, and also using the kind of standard cookie authorization. So in web applications, it's often the terminology is mixed up. People just say it needs auth. Well, there's authn, authentication, and authorization, and they are two totally separate things. So authentication is the act of getting some kind of authorization token. So in the case of a lot of modern apps, you might do an OAuth flow, you might do some biometrics, some two-factor authentication, but what you end up with is an authorization token, like a JWT bearer token being the most common. And then that's what's sent on every single request. In this particular type of authentication, which is a little more old school, is we're using traditional form auth and we're using cookies. So again, gray box kind of style comes into play, and we can tell the scanner what all the cookie names are that we want it to track for authentication. So this becomes important because the scanner will use these cookies, and in this case it's one, but you could have many, and we'll use those cookies and track if they're being reset or unset, and it helps the scanner stay, again, in an authenticated state so that it can scan as much of the application as possible. The username and password auth is fairly self-explanatory, but just to cover it, this is the page that will have the login form, this will be the page with the login form. This will be the page that we post authentication to, so where we actually post the credentials to. And in the case of our tool, we have this concept called the test path. And the test path is in the scanner will be exercised after authentication is confirmed, and it will be used to say, hey, does this look the way I expect? Am I actually authenticated? And again, super important part of DAST is getting authentication right. Because if you don't have it right, what will happen is you'll launch your tool at your app, and it essentially will just get 401s or 403s, and you might give you the false sense that my app is working, or my app is vulnerability free because everything was denied. You didn't really do yourself any favors, unfortunately, at this point. So that's where you confirming that auth is working is a vital part of getting API security testing working, or effective, I should say. So that's what you're seeing here. So the flow in the scanner will be to load the configuration, perform an authentication, check that the test path returns what it expects. And in this case, we have a pretty free-form way of doing this. You can put all kinds of regex and check for different status codes and things like that. So that is the core of this. There in this repository, there are a number of other examples of different styles of auth, different styles of getting routes. So in this case, where the default is to just perform a traditional spider, which you'll see here shortly. But you can feed it an open API spec, which is also something that we have in this project. So there are open API specs, and I'll show some of those scans a little bit later. And lastly, we have this in here, which is, this is a mechanism to say what type of what severity of vulnerability do we want to exit with a non-zero exit code. So this is a handy configuration for breaking the build. So I have this set to high. If any high vulnerabilities are found, we want it to crash, essentially exit with a non-zero exit code, so it could break your build system. Hopefully everybody's following along. I know that's a whole lot to cover in a very short period of time, but we will go ahead and kick off a scan. So again, I'm in the directory with this file. I'm in the same directory. You can leave the config file off. It will look automatically for stackhawk.yaml, but in this case, I'm just going to go ahead and specify it just to be more explicit. And now we're running a scan. So this scan is running against the application that I ran over in this terminal, boot run. And we'll see we kick out some banners and a little warning that my version is already behind because we released a new version this afternoon. So, but don't worry about that. It's just a warning to stay up to date. It'll work fine without it. So at this point, it's configuring the engine, and there's the authentication I was referring to earlier. So it's confirming that authentication was successful via the test path. And then we're seeing the spidering, and this runs pretty quick. And we can jump back into here to the platform and see that it's starting to report back the current running scan. So right now, this is running the active scan. So the spider was complete, essentially found all the routes, and now it is attacking each individual route with various different types of tests. These plugins here are different classifications or categories of tests. So remember I was saying there's mostly a CWE-based system. There are some plugins that target very specific CVEs, but for the most part, they target classification. So cross-site scripting is one that we're going to be looking at quite a bit today. And it's running through each of these tests. And each test run you see here, each number represents an HTTP request. So I'll quickly show the app here. And you can see a whole bunch of logging where the scanner is just attacking the app. It's just sending all kinds of interesting payloads and things like that. And these plugins are jamming through. They go pretty quickly. And you can see here in these tabs, we have the paths, again, the same stuff that was in the terminal being reported over there. And findings are starting to come in as well. So again, this is a purposely vulnerable app. And because it's purposely vulnerable, of course, we have some nice juicy ones in there that we can noodle over. Go back to the scanner. So the scanner is actually complete. It is just finalizing, sending the logs to the platform and kind of finding data there. And here is our over the threshold error. So that config here, I said, if you find any highs, I want you to break the exit with a non-zero exit code. And if you don't know this command, this is super handy. This will now tell me what the exit code was, and we lovingly exit with 42. The terminal output shows a nice summary of what was found, but it's not the complete details, as you can see. So like we have this proxy disclosure one. It's just enough to kind of give the person in the build pipeline an idea of what happened. But ideally, you come to the platform and you see that the scan result is complete, and you can start to look into findings and look into the details of what is going on. So we are going to focus on a couple of things here. You may notice this cute little logo from our friends at Snyk. So Snyk is a SAST tool, and one of the features that we support is the ability to cross-correlate the DAST findings with the SAST findings. And the reason this is interesting and is kind of a powerful feature for your AppSec program is, as I noted before, SAST can often be noisy and a little ambiguous. It just says, I found a pattern in your code that's probably bad. But if the DAST tool found it and the SAST tool found it, this is probably something you really, really need to look at. So in this case, this is not the vulnerability we're going to triage or work on, but it is a good example of kind of matching up the findings, as similar with the cookie without secure flag and things like that. So I'm going to go ahead and just click into one of these. And you can see here we have this little Snyk code tab kind of telling you what it matched on. And in this case, Snyk is a little funny. They don't give you the actual snippet back in their API. It's a different problem. We also integrate with CodeQL, which is GitHub's scanning tool, and it will show the snippet. However, we do link directly to the repo. So in this case, you can click right on it and it will take you right to the repository and the part, the code that Snyk said, hey, I think this is what's responsible for this finding. So that's a pretty cool feature. In the evidence side of it, this is the DAST findings here. We show a bunch of documentation on kind of describing what the type of vulnerability is, what some common practices around it might be, or common ways this might be a problem. We also show the paths that are involved. And in this case, there's only one path. I'll show some other vulnerabilities where there's multiple. But the important bit is, because this is a dynamic test, the request and the response bodies and headers are vital for triaging and recreating and understanding what did this tool do. So this is where as an AppSec professional, you can start to dig in, or you just send this link to your developers and you make them dig in because they're going to often have a really good idea of what's going on in that route, what these payloads should and shouldn't look like. And hopefully the descriptions here about what the vulnerability is will give them a clue onto, oh, that's what I need to go change in my config or in my code, or, oh, my framework works this way, that's why I need to do this. So in this case, we're looking at the request. The evidence of this particular finding identified by the scanner is, of course, that cookie that is not configured correctly. And in the response, we highlight in red the evidence and where it was found. So in this case, we have a set cookie that has no security parameters on it whatsoever. And the tool is saying, hey, that's not cool. Please go do something about it. And if you remember back here, if you're a developer and you have the SAST integration as well, boy, you just took them right to the code and your developers love you and you're the hero. So that's what we're looking to do here, is shorten that loop and make it so developers can get to this stuff as fast as possible and not beleaguer a lot of meetings and trainings and things like that. So we'll go look at another one. Let's go look at cross-site scripting, right? This is everybody's best friend / worst enemy. So this is a classic one. It's cross-site scripting reflected. So this is the case where essentially you have unsanitized input or output. So you, in some cases, it's totally fine that you send in a script tag or an HTML tag into your database and into your system, but it's not fine that your app actually renders it. So again, lengthy descriptions about what the attack type is and what to do about it. And in this case, the request response payloads. Once again, the evidence showing the unsanitized script. And in the response, we have the headers and body. So the headers in this particular case are not that exciting, but oh, where did my evidence didn't get highlighted, and there's a bug. Good times. So in this case, the script alert here is coming through unsanitized. This should have been highlighted. I'll have to talk to our engineers about what happened there. And as you saw on the other one, the evidence was highlighted. So this is the vulnerability I'm going to actually fix in the application. And I'm going to show you just that it goes away. We run a scan and we can run it a few times and it will just disappear. We also, this is a feature of our platform and a number of others, another of our tools, which is you can triage it. So sometimes there's false positives. You know, even the best tool might have a false positive, or perhaps it's not that important to the business and they don't care if that's an issue. So for example, we come back here, there's a number of lows, or, you know, maybe there's just stuff they don't care about. So we have the ability to do things like assign this, so you can hook up Jira or Slack and you can have it send this information to your developers, or you can just start to say, I want it to be risk accepted or false positives. I'm going to go ahead and do this to one we're not going to work on, just for context's sake. So here's an example of the content security policy header not being set. And, you know, I for whatever reason, my business doesn't care about it. So I'm going to come in here and say, you know, this risk is accepted. It's fine. And things like that. And we'll go ahead and mark this one as false positive. B. And then here we can see that we are starting to, you can see some of these counts are shifting. And what this is doing is it's telling the platform that, hey, even if you find this vulnerability, don't report it the same way. And for demonstration purposes, this is kind of contrived, but where it comes in to be really handy is, like, let's say your developers are working on a bug, right? They're fixing it. So they've come in here and they've said, we're gonna assign all of these, and, you know, somebody's, you know, Jim's got it. Jim's working on it, right? And we don't want to break every build. So he's going to come in, he's going to set all those. Yeah, there we go. Refresh. Yeah, so we mark these all as assigned. And so what this is going to do is, if you remember back here, we set this failure threshold. And if we had the failure threshold set at medium or some other value that would trigger on that vulnerability, once you've assigned it or marked it risk accepted or false positive or triaged it in some way, that tells the scanner, hey, don't break the build. Like, we're working on it, right? Sometimes these problems can take a long time and you don't want to stop the development pipeline. So kind of getting back to, you know, how to best use these tools in your software development pipeline is you have to have these capabilities to give your developers time, but not stop your scanning and not stop your development. So again, it's like the managing of the process is a lot of what we're focused on here. Okay. All right. So without further ado, I am going to get to some fixing. So in this case, cross-site scripting reflected is going to be the vulnerability I'm going to target to fix. And this is going to be kind of underwhelming, but it's a good demonstration of just how incredibly nuanced both the discovery of these type of findings is, and also how simple the fixes can be. So as I noted, like Juice Shop is a training app that's really, really designed to like exercise your skills as a security pen tester and a professional. But in a lot of cases, most people's apps are in pretty good shape, and maybe they just need to flip one config setting or enable in their framework, include the security header or whatever it is. So in this case, we're using Spring, and Spring has a templating framework built into it called ThemeLeaf, or I don't know how to pronounce it. It got funny names. But anyway, it's a templating framework that absolutely has the capability to not allow script tags and HTML and other things to be injected. But it also allows you to sidestep that protection. And so this is a classic case where a developer might be working on a cool feature, and that cool feature might include rendering some HTML, and they're struggling on the best way to do that. So they find this little feature in ThemeLeaf that says, oh, wow, this will just let me pass through unescaped characters. Well, that's exactly what's going on here with the cross-site scripting reflected. So ThemeLeaf has this ability to templatize the search text that I pass in. So if you remember from our app, we have this search bar. Oop, got logged out, pardon me. And we have this search bar, which takes input. And this input goes all the way to the database, and also it's also the way this app was designed, it reflects back. So if I search for something, it's reflecting back what I searched for. So again, our vulnerable app tries to do things that are pretty common, right? Like it's very common to have an application that you search for something and there's a little text below that says, your search for blah returned n number of results. So that's kind of what we're replicating here. And in this case, like I said, ThemeLeaf, and we have this noted in the app. So again, this is a practice app. It lets you unescape text. And because we're allowing unescaped text to come right through here, it's causing a problem. And in fact, let's just go ahead and recreate this. So I'm going to come back to my vulnerability. And I'm going to take the text that the scanner said was evidence. And essentially this evidence is what it injected. And I'm going to go ahead and do it. And there's our injection. So you can see my alert 1, or I can say, bad guy. Ooh, an even bigger error. So in this case, I actually hit the SQL injection because it's really bad.
Yeah, this is juicy.
So this is some fun stuff, right? We could get in and do all kinds of wacky things. Let's see what we got here. Hey, so there's a good one, wacky. Or ISC2 is fun. And I can spell, I promise. Yay! So again, we're here recreating the vulnerability. We also this is another kind of cool feature that we have, which is we also support, because as you saw, I just took that evidence and replayed it essentially into the form input, the search input. We also provide this validate button, which this is the curl command of exactly what the scanner did. So this is a really handy bit of our system where if you open a Jira ticket through our Jira integration, we will actually include this so the developer doesn't even necessarily have to come in here to triage it. They can just go, oh my God, look at that. Look at this wacky search text, and I can recreate the problem. All right. So hopefully that's some fun stuff for folks. Now let's go fix it. And this is my favorite part, because so many times, you get into these negotiations with developers and they're like, oh my God, the security guy is going to give me a whole bunch of stuff to work on and it's going to break all my stuff and this, that, and the other. Here's the fix. That's it. That's the whole fix. Right. And most companies are using good frameworks and they're using tools that already have protection built in, but they've sidestepped them in some way, or they just didn't enable them for some reason. So I'm going to go ahead and stop my app. This is where if you're running with the jar file, it's going to be a little trickier to try on your own. But I'm restarting the app. I essentially fixed the vulnerability. I modified the template. So now this template won't allow insecure text. It won't allow unescaped characters essentially to come through. And I'm going to go ahead and rerun a scan. Oh, that pop-up, by the way, is because I developed this, and so I don't have the signed application. If you download our MSI or our PKG, all the tool is signed and all that, and it won't throw those little funny pop-ups and whatnot. And so here's our scan coming in. There's our spider again. Go to the platform and wait for things to show up. You might notice there's a few findings that were found before plugins are run. Those are what were called passive checks. So during the spider phase, it's looking at headers and things, just looking at content without actually attacking the application yet. So there are certain classes of findings that essentially can be discovered without having to fuzz or break the app in any way. And we'll go here and look, and all of our cross-site scripting checks have run. So, whatever, what's that, 70, 80 something checks and no cross-site scripting. Now we can even go in here and hit search. Oh, goodness. Right. I restarted the app. We have no database backed sessions in this app. And I'll try and you can see comes through nice and clean. And this is because it's been escaped. So because it's been escaped behind the scenes in the HTML, all of this is essentially encoded correctly so we can see the input, but it's not going to trigger the browser to actually run the script tag. And this should almost be done. Oh, yeah, just finishing up. Oh, there it goes. There we go. And the vulnerability is gone. You may notice that the SQL injection one went away as well. That's actually for kind of a good reason. So in the mode that I'm running in right now, it's using an internal database, and the SQL injection is actually somewhat of a false positive. If you check out this project and you look at the README, you can run this same application with a Postgres backend. And if you run it with the Postgres backend, the SQL injection is super consistent because it has a real database and all of that kind of stuff. So that's just a little bit of nuance of what's going on there. All right. Well, I made pretty good time here. That was about what all I had planned on showing. If I can, let me check my slides. Recreate, fix, triage. Yep, that's all the stuff. I did save a little bit of time for some QA if folks want to do that. You can ask questions, or yeah, I can stop sharing, whatever we want to do.
Thank you so much. I'm sure people will have questions. Prakash, do we have any questions so far coming in? Just hit Slido myself. Okay, no new question.
Can we adopt this for Django? That is a great question. The tool certainly works with Django. I will tell you something interesting. So about Django very specifically. Django has an interesting thing where it creates its admin ID as 0. One of the attacks that will run will actually try to drop data for ID 0, and it will crash Django hard. um, so I bring that up because it's a little bit funny. And if you look on this repository, I believe we have a Django app. So this is, I'll post this in the chat. This is actually, we sanitized this one to not have that particular issue, but this is a similar-ish app as that app, as the Java Spring Vulny one. But this is our StackHawks kind of test app for Django. So feel free to play around if your Python's more comfortable. I will say we don't maintain this one as much, but it's got vulnerabilities and it does have the protection of not dropping the admin user. So I think it does also require a little more Docker to give it a real Postgres backend because Django likes a real database. Oh, good question for mobile applications. Not for the mobile app itself. There are testing tools that will target mobile code and mobile behaviors through the emulators. But mostly what we do see a ton of is attacking and using Dast for the APIs that back the mobile app. So, you know, when you say application, it's a little bit of a trap terminology nowadays, but the APIs that are behind it, whether you have a single page app or a mobile app, or oftentimes it's the same API for both, absolutely, we see that all day. So the short answer is the API side, absolutely. The app emulator side, there are specialty tools for that, but whether you call that Dast or not starts to get into some philosophical discussion. But the APIs for sure. And in fact, not to toot my own horn, but we were the first Dast tool to support GraphQL on the market. So we pioneered that technology specifically for our customers who develop mobile APIs using GraphQL, which is arguably one of the most popular API frameworks for mobile backends.
I do have a question on my own. So I'm curious to know, does StackHawk support checks for OWASP top 10 if that's what my organization is looking for?
Yes, absolutely. So the plugin summary here, there are a number of checks in here. And in fact, I'll go ahead and open the policy editor as well. But those checks do encompass the OWASP top 10. And we have a number of other checks in the policy that I didn't enable. Look at that, I'm using the wrong policy. Still pretty good. Oops, let's go customize policy. And in here, we actually have a number of checks for the OWASP API top 10 as well. So I didn't have all plugins enabled. You know, I'm trying to keep the scan moving fast. So you can come in here and activate or deactivate any number of plugins based on what it is you're looking for. So in this case, I kind of tuned it for the app. So again, gray box testing, and I'm only testing what I want, but there are checks for if you want to do, you know, BIFLA and BOLA and some of the more advanced API things.
Right.
There's also checks for things like, let me see if I can find it. There's like Mongo checks. So if you have Mongo database, it'll check for that. Why are some scans skipped? So great question. That's because they were disabled in the plugins, so or disabled in the policy. We also have, and in fact, I ran this without realizing I'm not using the default policy. There's two reasons though that checks will get skipped is you've either disabled them in the policy or you've disabled the technology flags. So the technology flags in here, the policy and the technology flags kind of interoperate. So certain checks will only run for certain technologies, and also certain checks will run more tests or less tests based on the technologies you've chosen. So in this case, this is again coming back to the gray box concept. I have tuned this to the technologies that I'm using. So I know that this app only uses Postgres, so I skipped all these other database checks. And I'm doing this for speed. So if you're going to put this stuff in your development pipeline, it becomes really important to keep this well-tuned for speed. Now, you can also break this up. Like, let's say in your development pipeline, you want to have one highly tuned that only checks for the technologies and policies that are most important or that you already know about. But then you maybe run a nightly scan where you have every plugin enabled and you try to make it beat up the app even more. That's a mixed bag because enabling or disabling certain technology flags can also help reduce false positives. So you really have to kind of know your enemy a little bit when it comes to the app. Now your app shouldn't be your enemy, but if you think about it from an offensive security perspective, it's knowing the weak spots or knowing what to attack most effectively. And actually, I should set this back to the default. We also, this is unique to HawkScan, but we have some interesting technology in our platform where if you just set the default policy, we will actually look at your configuration and see what you have enabled. So if you've enabled OpenAPI or GraphQL, we will go ahead and choose this custom policy tuned for your technology automatically. That's a very unique feature to StackHawk. So,
what if I want to customize further and dig? Do you have any custom scripts that I can use or templates that I can use to customize away from what the plugin provides?
Yes, absolutely. So this is another really powerful feature of our system is I have this directory here called Hawk scripts, and I'll open up another one of my configuration files that uses it. So these are scripts that are often used for like weird authentication systems. A lot of apps have, non-standard auth things. We support a lot of stuff out of the box, but if you need to, let me see if I can find one. Yeah, auth script multi-form. So here's an example of a configuration file where there's multiple steps involved or multiple form inputs. It's just kind of non-standard stuff. And because of that, we support the ability to write Kotlin scripts or Java scripts. I will say the Kotlin engine does have a few more features than JavaScript, but it allows you to customize the authentication flow. So let's see if I have my editor working here. So in this case, we'll go back to this config. So in this case, I have this add-on script. You give it a name, what type of script it is, and where it lives. And then, let's see, somewhere in here. Oh yeah, and then in here under authentication, we've configured, hey, use my script. And these parameters are actually free-form. You can decide what these are in your script. Same with the credentials. These are all totally up to what you build in your script. And you can get pretty nuts in these scripts. I mean, our SAs and our support folks have created some very, very elaborate scripts. And I'm feeling kind of silly, but you can also create your own checks. So I don't know if I have it in this project, unfortunately. I think I have it in some other repos, but you can also add in custom scripts. So you can register your own checks. So let's say you have, let's say you want to look for some kind of PII, or you have a policy in your company that says, we never want to see this kind of data in any of our payloads. You can actually write a script that hooks in and becomes a custom plugin. So when you run it, it will show up. Let's go back here. It will show up in the plugin summary here. You'll see your custom script as one of the checks. And then, of course, if it's found, it'll show up as a finding. I thought I had it in this project, but it might be in one of my other ones. Let me see if I'll paste another link because we have a HawkScan examples repo. Oops. Excuse me. Right, yes, here we go. Scripts, samples. Oh, those are all off ones as well. you know what? I'm just going to post our docs. Let's just go to the source.
I'll stop being selfish here. Quite a number of questions have come in between when I started to ask my questions and now. So
okay.
I have quite an interesting one. Someone here is asking, what about Kafka? Can you use StackUp for Kafka?
I would say no. So, you know, technically anything that's an HTTP endpoint, you can attack. But Kafka is a pretty unique streaming protocol. I actually have a lot of familiarity with that technology, weirdly. So I actually worked with the founders of that project when they were in college on the first version of it, but different story, different life. I wouldn't recommend attacking Kafka. Now, what you can do that is kind of interesting is you can create injections, like you could create a script that does an injection of data that then gets triggered out of band. So we have a part of our system that allows you to trigger, and this is how we detect Log4Shell, which is you can inject something that then gets triggered later on in a pipeline. It's not as common as a feature that we use because usually folks want to test the kind of real-time nature of their app and not something happening kind of later down the road. But theoretically, you could write a check that injects data, your Kafka pipeline picks it up, and then kicks something off. But attacking Kafka itself, I don't know. I mean, if you want to find out if they have a standard HTTP endpoint, you could, but it might just hang, right? Because it's a streaming protocol and it's going to keep a long-lived connection and things like that. So. Now, certainly if you have APIs that send data to Kafka, absolutely you can attack those. What about channels in Django? I'm not familiar. I'm not familiar with channels in Django so I can't say. It does sound streamy though. If you point Dast at streaming protocols, you can get unexpected behavior because it will never close the connection, and so it'll just kind of wait forever. You can control that. In theory, I guess you could make a custom script that knows that it's a streaming connection and do something special with it, but you're getting in outside of the realm of kind of your standard HTTP dynamic testing for sure.
I have a couple of more questions coming through. I will start with the latest one. Please don't forget to use Slido. Most of the questions I'm taking here are from the chat. Joseph asked, for gray box testing, would we require authentication, which is basic auth token or API key prior to running the scan on a private REST API?
Yes, so it all depends. It depends on your app for sure. So if you have a way to run your API without authentication, like let's say you have a microservice and you have an authentication gateway, and the microservice itself can be run without authentication, absolutely. You can test it at its lowest level without authentication. So it really depends on your app. It's hard to say. Another cool thing that we support is with the authentication scripts is the ability to support multiple layers of auth. So we have a number of customers that they have their app in a staging system and they have basic auth and JWT because their basic auth is what their QA environment uses to just get into the environment, and then the JWT auth is what they actually use in the app, and that's 100% supported and is a very good use case for custom scripts and in some cases just custom injection. So let me see if I remember where it is. So this is another kind of cool feature of our YAML config is we publish our configuration file to something called schemastore.org. And this is a JSON schema that we use. But if you use IntelliJ or anything that supports JSON schema, You will get auto completion inside of the editor. So when you're editing the YAML, I just hit Control Space, and this works out of the box with IntelliJ. I think there's an add-on you need to add, or add-on or extension, whatever they call them in VS Code and and other editors that support JSON schema. But in that, then you can start to dig in, and we have all kinds of fun features. Let me see if I can find the one. Probably have to reference my docs, but you can inject headers directly in. So kind of referencing, if you're using basic, you can just add basic into the config stack and let it do that. And of course, I don't remember what section of our config that goes into, but one of these things in here. And you can see this is a bunch of the other things that we support out of the box. So let's see. And I am, just because I build the software doesn't mean I remember everything in it either. So we have an extensive documentation section here. I'll post that link.
For sure.
Yeah,
I have another interesting question.
Yeah.
Let me know when you're ready for the question.
Sure. Yeah, this is the one I was going to add, is for headers specifically. Let's see if I can add on. So the replacer section is where you can match rules or inject new rules. So you can inject new headers. This is a pretty powerful feature. If you don't want to go all the way to scripting, you can inject all kinds of custom stuff commonly used for a lot of people like to run in their QA environments. And what they will do is add a header in here that says, I'm this scanner, or I'm the HawkScan scanner, and I'm doing this. And so that way they can figure out, was it the scanner causing problems, or their QA systems, or their Selenium scripts, or things like that.
Friendly fire, basically.
Friendly fire, exactly. So yeah, that's all I wanted to show there.
Okay, so for the question, and a good thing that you talked about injection and friendly fire so far. One Einstein, interesting name, is asking, do you provide any false test related functionality, or is there any feature that StackUp provides that can offer some form of false testing?
False testing?
Fuzzing your API.
Oh, fuzzing, yes. So that's a great question. So a lot of the tests that you see running in these plugins, as you saw from the injection, essentially are fuzzing.
Right.
So this is where, if you want to write some custom fuzzing, there is actually an embedded fuzzing library, and that is where getting into the custom scripts could come into play here. So this is where, if you want to get in and start to do really weird stuff and run through a whole set of your own fuzzing things, but essentially, this is an interesting question, because fuzzing has different meanings under different contexts, right? So you have like binary fuzzing and things like that. But essentially, all of the tests that we are running, all these active plugins that you see here, are some sort of fuzzing. So in the case of path traversal, right, 117 tests were run. And if you're really interested, when you run the app, you can enable you could enable HTTP logging, or you could even set up a listener. We also have a mode, if you want to get really weird. You can run this flag, and let me just go see if I can. I'm just going to open up the help here, because I think this will shed some context. But each one of those tests is essentially fuzzing something, a path input, a query input, something like that. And if you're really interested to see everything it's fuzzing, you can add this log HTTP flag, and that will dump all of the HTTP traffic to the log file. The log files are all written when you're running locally to this directory. And all of this is in our docs too, by the way, so you don't have to remember all of this. All of our logs are written into the ~hawk session directory, and then I am grabbing my scan ID. So every scan gets a unique ID, so it won't mix up your logs too much. there's a HawkScan log here. So that's the file. And then I'm going to go ahead and dump this. And obviously you don't expect to read it. But in this case, and I'll go ahead and run one. This will be fine. So this just dumped our whole log there. But I'm going to go ahead and run that last scan, but I'm going to add 2 flags to the scan. And this is going to be overwhelming, so be ready. We're going to do verbose. So verbose is going to say dump all the logs to the foreground. And then we're going to say log HTTP. And get ready for pain. But this will actually show every single HTTP traffic command that is going to be run against the scanner. So you can see the fuzzing if you want. Under normal circumstances, we're not showing all that, but yes, fuzzing is a core part of the technology that's happening here. Right now, it's just starting up, calling the API, loading the policy, and then there you can see this is the pain.
And you should be able to dump this to a text file or something similar.
It's being dumped to a text file automatically. So that was what was going on here. And again, it's by scan ID. So when we run a scan, every scan gets a unique UUID, which can also be copied from the platform. Let it get it. And in this case, this log should be significantly larger because it's dumping all the text in here. So now in this point, you can grab the scan, you can grab the log and all of that kind of stuff. Also, when the scan is complete, and as you can see, the pain is continuing. So, and the log file is growing. We also have, if I remember correctly, I believe we have a command to retrieve the log. So logs will be uploaded to our platform and you can download, I believe it's download, let me double check. Yeah, so you can do download log. And download log, you can give the scan ID and you can have it pull down the log. So let's say your developers are running and they run into a weird problem and you had them add the -- log HTTP command. You could then go download scan log, grab your scan ID, and here I'll go grab not quite as large a one to just save some time. And this should download the log file. And it's dumping it to the foreground. So of course you can do it to something like scan log. Scan dash, let's name it after our ID. Log. Oops. That's going to just pipe the output to that file. And I'm doing it in the Java Spring Vulny directory. And we can come in here. Here's our scan log, and we can start to peruse through everything that happened. So
I have another interesting question.
Yeah.
What would be your suggestion? And this is from Curti, and he's asking, can he, for example, deprioritize a finding, especially when he has control? For example, a CSP versus CSS protection is provided on the infrastructure level already. And for example, the WAF rule already has OWASP top 10 applied at network layer. I know AWS does this already, so it wants to find out if he can deprioritize a finding.
Yeah, so it's a little bit of what I was showing earlier is there's a couple ways you can do it. So if you don't want to run this gets into a little bit of a philosophical question. So, the way I look at WAFs and things like that is like hiring a bouncer, right? Or a bodyguard. Mm-hmm. So like, let's pretend your app's a celebrity and you hire a bodyguard. But running a tool like dynamic security testing, a DAS tool, is like teaching your celebrity kung fu. So it doesn't need a WAF. It doesn't need those things as much. Now, that's up to your business and how they think about it. So I always say don't run through that. Like you want to see if your app can protect itself, and then you kind of have double layers of protection. That said, if you want to run a scan through that WAF infrastructure and you want to just deprioritize it, or just say, hey, we still want to scan for it, but we don't care, or we don't care as much because we believe our WAF's protecting us, that's where the triaging comes in. So this is this cross-site scripting. Well, actually, I fixed it in this one. So 1 second, I got to go put it back. So this is a part of our system. You can't actually triage on old scan data because we have a new record for that app. And that's where that app unique ID comes into play. So we're tracking its current state. But let me go ahead and put the vulnerability back and start that back up. And I'll rerun that scan shortly. But the net of it is you can come in here and essentially mark it as yeah, here's a good one. Like this one, cookie without secure flag. You can come in here and you can mark it as risk accepted. So what this says is it's fine, right? WAF's got it. So by doing that, when the next time we run a scan, you can see it moved the count of new over to risk accepted. And again, it will report that it was found, but it won't ever break the build, and you can essentially ignore it from a reporting standpoint. You may have also noticed whenever you do that, do something like that, mark it as risk accepted or false positive, we start to create a history log so you can keep track of who's marking things risk accepted and false positive and why you're doing it and stuff like that. So
Sure.
Go ahead and set that one back and say, oh no, please fix. And of course, we're updating all that. So hopefully that answered the question, but essentially that's triaging the findings and putting them in a state that says, this is okay. We're going to keep checking for it, but it's okay. If you want to be more authoritative about that, and you don't even want to run the check, and maybe the check is causing problems with the way you're scanning, that's where you would come in, customize the policy, remove the check altogether. So let's see if we can find, I think it's a passive scans. Cookie. So yeah, cookie without secure flag. And we could say, we don't care about it. Just don't check for it anymore. Kind of two ways to do it depending on your preferred stance. And we have a number of customers that what they really like to do is run lots of policies against the same app. So they have a policy that's their fast app. This is what they run in the pipeline. This is the one they run at night. This is the one the security guys run when they want to check everything. Totally flexible. That's one of the things we believe in, and kind of something old DAS from old DAS vendors. They would often charge by number of scans. We do not charge by number of scans. Most of the new vendors don't. We encourage scanning and scanning a lot. So having different profiles and different policies to kind of look at your app in different ways is a very powerful way to use these tools.
Awesome. We're coming up to time, and I would say this is the last question that we're taking. Still on the topic of forcing, incursion of mother tongue. Do we need custom word list, or is there a built-in library for the forcing?
It's a great question. Right now, you would need to bring your own word list, but I'm going to take that down because we do have an internal word list that we could start to expose in our scripting library. So, but right now it would be a custom word list that you would need to grab. That said, there's a ton of them on the internet that you could use. But I like that idea. I think we'll look into including ours.
Okay. Awesome. Okay.
Stop sharing.
Yes.
All right.
All right. So I'll go ahead and share the link for. Okay. Yes, we have that covered. And I was going to look for. I can't find my slide again. Where did I go? Where did I throw my slides? Oh no. I'm looking for it. I have a gazillion tabs open, that's why. Okay, found it. I was just gonna, oh yeah, so I see in the chat, the CP and feedback form is up. Please fill that out. But thank you, Casey, for that incredible and informative session. I'm sure everyone has gained a lot of valuable insights and practical knowledge. And as we wrap up, coming up to 8 o'clock, I want to take a moment to share a bit of personal story and my personal journey and how I fell in love with AppSec. Coming from the background of quality assurance about a decade ago, I used to love, I still do, but to a different degree now. I used to enjoy the thrill and satisfaction of finding and fixing bugs while ensuring that the products that and the features that we're churning out were of the highest quality before they reach end users. But there was always that feeling that I would get that there's still more to be done, especially around ensuring that applications are not just functional, but they are also secure. And one day it hit me. I was testing an application manually and I stumbled on a critical vulnerability. And this was an application that was sponsored by the World Bank. So it was like a moment of revelation for me. And I realized that beyond functionality and performance, there's an entire dimension of security that was just as crucial, if not more, right? And that vulnerability could have had severe repercussions if it wasn't fixed. And from that moment on, it wasn't just about functional bugs anymore. It was about protecting applications that I was working on and ensuring privacy and maintaining trust overall. And driven by that sense of curiosity and that new sense of purpose, I started to explore the field of application security. I'm self-taught, and you won't believe that I studied mass communication, but here I am today talking AppSec. I started to attend workshops, read extensively, even took up courses by myself. But what struck me was how similar yet different AppSec was to QA. Both fields shared the same goal, and Casey alluded to that early on when he said the work of an AppSec engineer, especially around API security and security testing overall, is like quality assurance, and that's why I'm sharing this. You know, the more I learned about AppSec, the more I fell in love with it. I combined that passion for meticulous testing with a deeper purpose for protecting applications. And that there was a thrill when you discover a bug, just like how it was exciting to see XSS earlier on in SQL injection, right? It's really exciting. And today I stand here or sit here, as the case may be, confidently saying that I'm choosing to delve into AppSec, or choosing to delve into AppSec was the best decision I've made so far. And it's a field that would continuously challenge and excite me. So I hope that through this workshop, you've been able to, you're able to gain an appreciation of the importance of application security. So it's not just about finding and fixing bugs, but also building robust and secure applications overall that users can trust. So who knows, maybe some of you will fall in love head over heels with AppSec as I did. But all this to say, thank you for joining us tonight. Please don't forget to fill out the CP survey links using the link provided in the chat. Your feedback is also invaluable to us. And for our July events, let me just bring that up. I've gotten carried away by AppSec. Don't mind me. Watch out for our July event. I don't have the exact dates right here, but that's coming up sometime soon, and be on the lookout in your emails. So with that said, you feel free to turn on your camera. It's networking time. It's 8 o'clock. And if you have any questions, comments, feel free. Now is the time. Don't be shy. Thank you once again, Casey.
Yes, thanks for having me.
While we still have Casey here, feel free to ask questions. Going once, going twice.
Hello?
Oh yeah. Oh, someone is here. Why do we like pressure? So much pressure.
Okay. So I just got into well, although he rightly said that he has not done much about Kafka, but I just realized that a lot of problems can also be solved by moving our applications to event-related solutions. And that's still missing in the world. I mean, let me say that there are few applications going into that. I'm a software engineer. I just moved to Canada, so I'm just wondering if this kind of testing can be dipping into event solutions, and so let's know what we are facing. Let's know how to also tackle it. I mean, if you guys can actually move into that, I mean, do more extensive work on event-related solutions. That would be great. It's just a comment. It's not a question. Yeah.
I'll leave that to Casey to answer. Casey?
I wasn't totally paying attention. Sorry.
It was talking about
so more event-based applications. Are you? Did I say you heard that right?
Yeah, I was saying that Kafka, it's one of the biggest in that sphere. Then the minor one are the channels. So I'm now saying that, I mean, I've done extensive research on it. I've been using it for a while now. And I just realized that, okay, now what about if this breaks? I mean, is using event-related solution. I mean, most applications that are real time are really making waves, and we must be able to test that. We must be able to, stop that guy that is trying to prevent this from working, So I'm now saying that it would be good if you guys, I mean, you've done extensive work here. I didn't even know that my Django is having a lot of bugs and I need to find that, how to use that for Django, most of my applications that I've actually built. So I'm now saying that, can you do more testing, more related to findings on how to, also protect these event-related solutions,
Yeah. So there's an acronym that is eluding me, but essentially, like Kafka and the pipeline technologies and where the data ends up is, it's kind of an artifact of where maybe it came from. So the common architecture is something like you have a web API, right? Let's say you have a single page app and it talks to an API. You have a mobile app and it talks to an API. Very rarely that I've seen anyway, are you talking directly to Kafka. Usually you hit an API and then that API puts data onto a queue like Kafka, and then that data gets processed and put somewhere else. So that type of testing is often called